Welcome to the series of Artificial Intelligence in Mechanical Engineering. This is Dr. VVSH Prasad, Department of Aeronautical plus Mechanical Engineering. And today we will discuss about the introduction to AI, process challenges, applications and decision. Today we will understand about what is machine learning. The typical workflow for building a machine learning system involves several stages. The first stage involves the problem definition. Clearly define the task and the desired outcome. Data collection. Gather relevant data from various sources. Data preparation. Clean, pre-process, transform data into a suitable format for modeling. Here clean means there will be some sort of irrelevant or there will be spikes in the data, and such data should be cleaned, and we have to transform this data into a suitable format for modeling. That we call it as the data preparation. Data collection from the various sources and what you are expecting, that should be your problem definition. Feature engineering. Select, modify or create features that enhance model performance. Model selection. Choose an appropriate algorithm based on the problem and data characteristics, and which model has to be adopted for to get the best output. Model training. Use training data to fit the model by optimizing its parameters. Model evaluation. Assess model performance using testing data and relevant metrics. So, model training will be done by using the training data, and we'll use this model to evaluate the real-time test data, and we'll observe the performances with the model training and model evaluation. Hyperparameter tuning. Optimize non-learnable parameters to improve the performance, and these we call it as the hyperparameters. Then do the deployment, integrate the trained model into production environment for real world use. Monitoring and maintenance. Continuously monitor model performance and update as needed. There are certain challenges in machine learning: overfitting and underfitting. The diagram represents three cases where there is an underfitting is there, overfitting is there, and appropriate fitting is there. Let us define what is overfitting and underfitting. Overfitting. The model learns the training data too well, including noise and outliers, resulting in poor performance on new data. So that we call it as the overfitting. So overfitting, force fitting too good to be true. The model is too simple to capture underlying patterns, leading to poor performance on both training and test data. There will be a bias trade-off, that is bias variance, error due to overly simplistic assumptions in the model. High bias. When you see the size and price of the house, when you consider, definitely the bias is high. Underfitting actually. So when you see here the third curve, that is high variance, low bias and low variance, and as the problem you can see theta naught plus theta 1x. Here theta naught plus theta 1x plus theta 2 x square, and here high variance, that is overfitting, is trending up to the variable x tends to n. Variance. Error due to sensitivity to small fluctuations in the training set. The goal is to find a balance that minimizes both bias and variance for optimal Generalization. Generalization. That is what we call it as that is the challenge in machine learning, bias and variance trade-off. Trade-off means where they will be optimally meeting to give the best performance. Regularization techniques such as L1 and L2 add penalty terms to the loss function to prevent overfitting and improve the model generalization. So where you go, here the theta 1, theta 2, theta 3, those values will be updated by regularization, and we are going to prevent overfitting and improve the model generation. Cross validation. Cross validation involves partitioning the data into subsets, training the model on some subsets, and validating it on others. This helps assess the model's ability to generalize and guides model selection and tuning. Applications of machine learning. Machine learning powers numerous real world problems, including healthcare, disease diagnosis, medical imaging, drug discovery, finance, fraud detection, credit scoring, algorithmic trading, retail, personalized recommendations, inventory management, demand forecasting, transportation, self driving cars, route optimization, predictive maintenance. NLP, that is natural language processing, chatbots, language translation, sentiment analysis, image and speech recognition, face detection, voice assistance, biometric authentication. Then, what are the popular machine learning algorithms which can be classified as we have told that which will be both supervised and unsupervised algorithms will be there, wherein the type of algorithms goes from linear to k nearest, and typical uses of these algorithms: linear regression, that is a supervised type, predicting continuous values; logistic regression, it is a supervised binary classification; decision trees will work for both for classification as well as regression, it is a supervised one; random forest, it is a supervised one; assemble learning classification; support vector machines, supervised classification and regression; k-means clustering, unsupervised, grouping similar data; principal component analysis, it is also an unsupervised one; dimensionality reduction; neural networks, both complex pattern recognition, it is both supervised, unsupervised is there; navy base, supervised text classification, spam detection; k nearest neighbors, supervised classification and regression. Then what is a decision tree? A decision tree is a visual representation of decision making process. It resembles a flow chart with nodes and branches, where each node represents a decision or an event, and each branch represents an outcome or a possible path. Decision trees are widely used in various fields such as data mining, machine learning, and operational research. Some key terms associated with the decision tree representation. As you see in the diagram, it is root node, then from the root node, it goes to the decision nodes. The decision nodes will have again left leaf node, leaf node, leaf node, leaf node. So typically it shows the root node will have two branches, that is decision trees, and from decision trees you are going to have the leaf nodes. Leaf node is the end and no further branching will take place. Starting point of the root of the tree representing the entire data set, branches, lines connecting nodes, illustrating the flow of decisions based on attribute values. Internal nodes, the points where decisions are made based on data features leading to further splits. So, this is can be an internal node. Leaf node, the terminal nodes of the tree representing the final prediction or outcome. These are there will not be further branching. Here we are having branching is there. That is what we call it as the internal nodes or decision nodes. The basic decision tree learning algorithm. This is as just now what they have explained, a decision node, and this can be a root node. From where it goes to decision node. This is subtree and this is also a subtree. From where it is leaf node, leaf node. Here this is leaf node, and again here there is a decision that has to take place. This is leaf node and leaf node. So we hope decision tree works by recursively splitting the data set based on different attributes or features to create subgroups that are as pure as possible in terms of target variable. At each decision node, a criterion is used to determine which attribute provides most information gain or reduction in impurity, enabling the tree to make the best decision. This process continues until tree reaches its maximum depth or a stopping criterion is met. This is what we call it as the depth of the tree, where that is the starting node or root node here. From here, leaf node, there is no further branching is required. A type of supervised learning method used for both classification and regression problems, popular due to their ability to handle both numerical and categorical data, their transparency and interpretability, their relatively high accuracy. The algorithm splits the data into smaller subsets until it reaches the final predictions. A final result is a tree with decision nodes and leaf nodes. A decision node has two or more branches. Leaf node represents a classification or decision. The topmost decision node in a tree, which represents to the best predictor, called the root node. Decision trees can handle both categorical and numerical data. It can handle noisy data well, data with errors, unusual values, inconsistencies, or irrelevant parts that can be negatively impact the performance of the machine learning models, and can learn complex rules by combining simple and or conditions, that is conjunction and disjunction conditions. Thank you. And this is what about the decision tree, and we have discussed the challenges also. In the next session, we will see how to do the classification by using a decision tree. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.